Back in Algebra 1, we learned how to multiply a binomial pair by using the FOIL method. I'm not a big fan of calling it the FOIL method because really all it is the distributive property. So when you multiply x minus 6 times x minus 2, you have to multiply the x times both terms in the second set of parentheses. So you would take x times x, and x times x is x squared. And then you would take x times negative 2, which would be negative 2x. And then you take negative 6 times both parts in the second set of parentheses. So negative 6 times x would be negative 6x. And negative 6 times negative 2, so since that is a negative times a negative, that would be a positive and a positive 12. And then you combine your like terms. Most oftentimes, those like terms are the two terms in the middle. So we would combine negative 2x to negative 6x. That would be negative 8x. So notice I've already brought down the x squared. So that would be x squared minus 8x, and then there is no like terms with the positive 12, so that'd just be plus 12. And that would be the answer. That would be the simplified form of x minus 6 times x minus 2. And then earlier this year, we discussed how to factor a quadratic expression into binomial pairs. So notice that the answer to this question is the start of this question. So we're going to be going in reverse, trying to figure out what binomial pairs multiply to be x squared minus 8x plus 12, even though we already know the answer. So we would open up two sets of parentheses, and then we would split up the x squared, and that is going to go here and here. So that would be x times x equals x squared. And then you got to figure out two numbers that multiply together to be 12, but that when you check your insides and outsides, they add up to equal negative 8. And there are lots of numbers that multiply to be 12. There's like 3 times 4, and there's 6 times 2, and 12 times 1. But which one of those would give us outsides and insides when we check them that would equal negative 8? And that would have to be negative 6 and negative 2, because negative 6 times negative 2 equals positive 12. But when we check our insides and outsides, we get negative 6x, and the outsides is negative 2x, and that does add up to the negative 8x that we need. So that would be the factored answer right here. The horseshoes down here are the way you check your answer, but the x minus 6 and x minus 2 is the actual answer, and we did that earlier this year. That is the basis of what we're going to start doing today, which is solving quadratic expressions and quadratic equations by factoring. In other words, not trying to put them on a graph and see where the x-intercepts are. Solving quadratic equations by factoring is an application of the zero product property. And what the zero product property is that if you have two numbers, a and b, and if a times b equals 0, then either a equals 0 or b equals 0. So if you're multiplying two numbers, and if the product of those two numbers is 0, then at least one of those numbers has to be a 0. It could be both of them, but at least one of them is. And 0 is the only number that works with. You can't do that with any other number. I can't say that if I have two numbers, A and B, and their product is 4, I can't automatically say that it's A is 2 and B is 2, because A could be 2 and B could be 2, or maybe A is 4 and B is 1, because 4 times 1 also equals 4. So like I said, 0 is the only number that this works with, because if you multiply two numbers to get an answer of 0, one of those numbers has to be a 0. The way we use that in quadratic expressions and quadratic equations is that if you have two factored binomials and their product equals 0, then either the x plus 3 equals 0 or the x minus 5 equals 0. Because if x plus 3 equals 0, that means that you would have a 0, and when you distribute it into the next set of parentheses, it would also be 0, which means the total is going to be 0. So the way that we do solving quadratic equations by factoring is that we first and foremost must have the equation set equal to 0. And if it's not set equal to 0, you move everything to one side of the equation so that it is set equal to 0. Then you factor it. And then you set each part equal to 0. And sometimes even if you factor out by distributive property, you also set that equal to 0. And then you solve each equation when it actually turns into fairly simple Algebra 1 style equations after you factor it. So factor using the GCF, it says 16x squared plus 8x equals 0. Now, since we do have an exponent of 2 here, we do know we need to solve this by factoring, at least for now. There are other ways to solve quadratic equations that we'll get to later on, but for right now, everything that we do is going to be factorable. So since we're solving it by factoring, it must be set equal to 0. And again, if it's not set equal to 0, you set it equal to 0. So first thing we do when we factor is we look to see if we can take anything out by distributive property. And they both contain an x, so we do need to factor out an x. And 8 goes into both 16 and 8. So the greatest common factor of 16x squared and 8x is 8x. So then I'm factoring out the 8x by distributive property. And then 8x times what is 16x squared? Well, that would be 2x. And 8x times what is 8x? Well, that would just be a positive 1. So I factored 16x squared plus 8x into 8x parentheses 2x plus 1. That's still going to be set equal to 0. And then to solve for x, we're going to set both parts of those equal to 0. So what we factored out, the 8x will be set equal to 0. And the 2x plus 1 will be set equal to 0. And you'll notice that when we do that, we get two fairly simple equations to solve for. On the first equation, we would divide both sides by 8. And 0 divided by 8 is 0, so x equals 0 on that part. And on the second equation, we would first subtract 1 from both sides. So 2x equals negative 1. And then divide by 2. And so our second answer would be just negative 1/2. So we actually have two answers, as we've already known from a previous lesson, that oftentimes a quadratic equation crosses the x-axis in two places. We have two answers on here as well. And those answers are 0 and negative 1/2. Let's do another one. So part B is very similar. Can we factor anything out by distributive property? Yes, we can. 7 goes into both 21 and 14, so 7 can be factored out. And since they both contain at least an x, we can factor an x out. So we'll open up one set of parentheses because, again, we're just factoring by distributive property at this time. And 7x times what is 21x squared? Well, that would be 3x. And 7x times what is negative 14x? And that would be negative 2, because 7 times negative 2 is negative 14. And then x times, there's nothing to multiply the x times, so I would just take it up there. And now we're ready to set each part equal to 0. So what I factored equal to 0, and what's inside parentheses equal to 0. Divide both sides by 7 on this side, so x equals 0. And on this one, I would have to add 2 first. So that would be 3x equals 2, and then divide by 3. And x would equal 2/3. So my answers are, and again, there are two of them, x is 2/3 and x is 0. Here's some more. Solve each equation. This one is x squared plus 16x plus 64 equals 0. So it is already set equal to 0. It is a quadratic equation, so it is ready to be factored. This one's a little bit different than what we did up here because these, on this part, we could factor out by distributive property, but you can't factor out by distributive property on part A because not all three terms has an x, so the last term doesn't have an x, so you can't take an x out. And the coefficient of the first term is just a 1, and you wouldn't be able to factor out anything but a 1 there, so we can't factor out a single number. So that's, we can't factor out by distributive property. So we're actually going to do binomial pairs on this one, just like we did in the very first example at the very top of this lesson. So how do we split up x squared? What times what is x squared? So that would be x and x. And then what times what is 64? Because that will go here and here. But again, it has to add up to be 16x when we do our inside and outside check. So numbers that multiply to be 64 but add to be 16 would be positive 8 times positive 8. 8 times 8 is 64. But when we do insides and outsides, we get 8x and 8x, and that does add up to the 16x that we're looking for. So we do have it factored correctly. Once we get it factored correctly, we do set each part equal to 0. So we'd have x plus 8 equals 0 and another x plus 8 equal to 0. And we're going to get the same answer on both of these. So we would just have x equals negative 8 and x equals negative 8. So there's actually only one real answer on this one, since they give you the same set of parentheses and they both give us the same solution. It's just x equals negative 8. Remember on a graph that sometimes if the vertex touched the x-axis, that we only had one solution or one root. And that's what it looks like when we solve a quadratic equation by factoring. Part B says x squared equals 64. Well, if we're solving this by factoring, this one is not ready to be factored because it is not set equal to 0. So if it's not set equal to 0, we make it. So I'm going to subtract 64 from both sides so I can get 0 on the right side of the equation, and the left side of the equation would be just x squared minus 64. So how do you factor x squared minus 64? What's the middle term on this one? The middle term, or the b term, if you think about this in terms of a, b, and c, is 0. So what we're doing is that we're going to be looking for two numbers that multiply to be negative 64, but add up to equal 0. So x squared still gets split into x and x. And then factors of negative 64 would be negative 8 and positive 8. Because it's a negative number, you have to have one positive and one negative. Negative 8 times positive 8 equals negative 64. And then when we do our inside-outside check, we get negative 8 on the 8x on the inside, positive 8x on the outside, and that does add up to be 0x, which, again, our middle term in that situation is 0. So we're ready now to set each set of parentheses equal to 0. So x minus 8 equals 0 and x plus 8 equals 0. And then we solve each part. So we would do that by adding 8 to both sides. So x equals 8. In this one, we would subtract 8 from both sides, and that would be x equals negative 8. So that's the two answers on this one, which makes perfect sense because if you go back to the original problem up here, 8 squared does equal 64. And so does negative 8 squared, because negative 8 times negative 8 also equals positive 64. So both answers work in the original problem. And then part C down here, 4x squared minus 44x plus 121 equals 0. Well, first off, is it ready to be factored? And we know it is ready to be factored because it is set equal to 0. We can't factor anything out by distributive property because the last term, the 121, does not have an x with it, so we can't factor out an x. And there is no number that goes into 4, 44, and 121. So we're just going to have to go to a binomial pairs on this one. So what are two numbers that or two terms that multiply to be 4x squared? Well, there's actually x times 4x. That is one possible set. And then there's also 2x times 2x. I'm going to do 2x times 2x, but if I can't get 2x times 2x to work, I'm going to have to go back and try x times 4x. So I'm going to split the first term up as the 2x and 2x, and then two numbers that multiply to be 121, but have insides and outsides that add up to negative 44. And two numbers that multiply to be 121 happens to be 11 times 11. I'm going to use negative 11s on both of these. The reason I'm using negative 11s on both of these is because they need to multiply to be a positive 121, but they have to have insides and outsides that add up to be a negative number, in this case negative 44. So when I use negative 11s, I can multiply the insides to get negative 22x, and the outsides is also negative 22x, and that does add up to that negative 44x right there. So I do have it factored correctly, so I'm ready to set each part equal to 0. And just like the first example I did, we are only going to get one answer because both sets of parentheses are the same. So I'm just going to go ahead and just do it one time this time. So 2x minus 11 equals 0. I would add 11. So 2x equals 11, kind of running out of room here. Divided by 2, and we are algebra students, so I will just leave that as a top-heavy improper fraction, which is positive 11 halves. You could call it 5.5 if you divided it out if you would like, but 11 halves is good enough.